In lesson 6 and 9, we're going to be looking at what are finite and infinite decimals, and we're also going to be looking at decimal expansion. And yes, we are skipping lesson 7 and 8. So let's remind ourselves of how we turn a fraction into a decimal. You should have learned at least in 7th grade that you turn a fraction into a decimal by dividing the numerator by the denominator. So just to remind you, the numerator is the one on top and the denominator is the one on the bottom. So you would take the one on top and divide it by the number on the bottom. So let's try a couple. And remember, you can always use a calculator for this. If you don't have a calculator with you, you'll have to be doing long division. For this one right here, 1 over 8, to turn that into a decimal, we'd have to do 1 divided by 8. What I always see people mess up, though, is the fact that they'll switch these. So they'll do 8 divided by 1. Always remember to look at your answer, see if it makes sense. Because if you do 8 divided by 1, you'd get 8, and that wouldn't make sense. But if we do 1 divided by 8, 1 divided by 8, we get 0.12. Okay? And that's all we need to do. So if we have 1 over 6, we just need to do 1 divided by 6. Woof, and we get something that keeps going on forever. So we have 0.16 going on forever. And I know some of your calculators will put a 7 at the end just because it's rounding. So it really is 6 on for forever. So this is a repeating decimal. And you show that 6 is repeating by putting that line over it. You put the line only over the 6 to show that only the 6 is repeating. So what about 1 over 25 and 1 over 7? I'm going to have you finish those up. So remember, 1 over 25, you do 1 divided by 25, and 1 over 7, you do 1 divided by 7. So go ahead and finish those two. Ask me in class if you have any questions. So what these are leading us towards is the difference between a finite and an infinite decimal. And you might have already seen the fact that we have examples of both of those. So a finite decimal is one that ends, and an infinite decimal is one that doesn't end. So let's get those written down. So infinite decimal is a decimal that does not end. So it just goes on and on forever. Sometimes it's going to be repeating and sometimes it's not. But whether or not it repeats is still an infinite decimal if it goes on for forever. The finite decimals are the ones that do eventually come to an end. So it's a decimal that comes to an end or stops. We also will say that it can terminate, so the decimal terminates. And so sometimes you'll see a finite decimal also being called a terminating decimal because it ends. So looking at the ones we just did, which one is a infinite decimal and which one is a finite decimal? Well, this one comes to an end, so this one's going to be the finite decimal. And then this one, because it goes on for forever because it's repeating, is going to be an infinite decimal. So let's actually take a look at a couple more examples and see if we can identify which ones are going to be infinite and which ones are going to be. So here we have some fractions, and obviously in order to tell if they're going to be finite or infinite decimals, we're going to need to turn them into decimals first. So let's go through this rather quickly. So 1 over 34, I do 1 divided by 34, and I get 0. Now this is where it stops on my calculator. However, I tend to assume that if it goes all the way to the end, it's probably continuing on forever. This is not a repeating decimal, so I may not be sure, but I'm going to assume that this keeps going on for forever. What about 1 over 16? 1 over 23? And 1 over 5. So we have these ones as decimals, and now I really hope that it's pretty obvious which ones are going to be finite and infinite. Obviously, if you're going to be having to write it with any sort of ... etc., or the repeating line, then that's obviously going to be infinite. And any ones that actually end are finite. So this first one, we got a really long decimal, and then even still it doesn't end. So this one's going to be infinite. This one right here ends, it stops, so that's going to be finite. This one, we see it has that ... so that tells us it's going to be infinite. And what about 0.2? I'm going to let you finish that one up. Is 0.2 infinite or finite? We can always tell if a fraction is an infinite or finite decimal by essentially turning it into a decimal and then just looking at what we got. But maybe we don't have a calculator with us, or we don't want to have to go through that work. We just want a fast way of being able to look at a fraction and tell if it's going to be a finite decimal or an infinite decimal. Well, in order to know if there really is a shortcut, we're going to need to see if there's any patterns we can see. So what I have is just some numbers for us to look at. I have fractions here where the denominator is a product of 2. So 2, 4, 6, 8, on and on. And I have the decimals that go along with them. Then I also have the products of 3 for the denominator, 3, 6, 9, 12, on, and I have their decimals here. I also did the products of 5 and the products of 7, because they're the first prime numbers, essentially. So we're going to take a look at those. So right off the bat, I definitely noticed that anything that has a product of 3 is going to be an infinite decimal. So any denominator with a product of 3 is an infinite decimal. So there are some that are also products of 3 that are in some of these other ones, like this 1 over 6, or 1 over 12, or this 1 over 15, or this 1 over 30. So, and we actually see that holds up then, that these ones that were also products of 3 are still infinite decimals. So something else I noticed is that all of our products of 7 are infinite decimals. So let's write that down. So I'm just adding on to our notes. Denominator with a product of 3 or 7 gives us an infinite decimal. So let's see if there's some of those everywhere else. So, 1 over 14, that's a product of 7, and 1 over 35. And I can see that those also are infinite. So now thinking about the ones I have in the product of 2 and the product of 5, you might notice that the ones that were infinite before have now kind of essentially been summed up under products of 3 and 7. And that's because the ones that have just 2 as their factors, or just 5 as their factors, or a combination of 2 and 5 as their factors, are going to be terminating decimals, are going to be our finite decimals. So to sum up, essentially, what we saw is if you have anything with a factor of 3 or 7 in your denominator, it's going to be an infinite decimal. However, if you only have factors of 2 and or 5, you're going to have a finite decimal. So like if I have 1 over 10, the factors of 10 are 2 and 5. So this is going to be a finite decimal. Or if I have the factors of 1 over 14, because the factors are 2 and 7, that 7 is going to tell us that this is going to be an infinite decimal. Now, you don't always have to use this rule, and if you forget it, that's okay, or don't think it's too wordsy to remember, that's okay. This is just a nice little shortcut that will save you some work. But if you don't remember or don't care about it, you can always still do what I showed you previously of just dividing the numerator by the denominator, then getting that decimal, and then seeing if it's going to be infinite or finite. But for now, let's actually practice using this rule that we just saw. So let's take a look at some fractions and see if we can identify based on their factors if it's infinite or finite. So now let's take a look at 1 over 105 using the rules we just saw. So we need to find out what the factors of 105 are. Well, if we break down 105, we definitely have a 5, and that will give us 21. Then 21 breaks down into 3 and 7. And so we should remember that if we had either a 3 or a 7, that this is going to be infinite. So we don't need to use our calculator. We don't need to find out what the actual decimal is. We can already, just by looking at its factors, know that this is going to be infinite. Let's look at one more. 128. Well, it's definitely divisible by 2. Let's see, then 64 is divisible by 2. 32 is divisible by 2. 16 is also divisible by 2. Goodness. Then we have 8, which is divisible by 2. And 4 is divisible by 2. So every single one of our factors is a 2. And we just saw that anything that has factors of only 2s or 5s, or some sort of combination of both, is going to be finite. So this is going to be finite. What about 27? Well, we can break 27 into 3 and 9, and then 9 can be broken into 3 and 3. So I'm going to let you finish this one up. Look back. If I have factors of 3, is it finite or infinite? And then 625, I know at least that is divisible by 5. And then that's going to be, and then 125 can be broken in by 5, which will be 25. And then that breaks down to 5 and 5. So we have only factors of 5. So look back at what we just did and see if I have only factors of 5, is this finite or infinite? And finish that one up. All right, now we're going to finally get to decimal expansion. You've done number expansion before. You probably did a lot of number expansion when you were in elementary school, and then we also looked at the beginning of the year at looking at some number expansion, but we did it using scientific notation. So this time we don't need to deal with scientific notation. We're just going to essentially say what place value these numbers are in expansion form. So let's start with just a nice whole number and expand that out. So if we have 2,543, we just need to break it down at what number is in each spot. Now, I like to use parentheses to kind of group together my parts because it makes it easier for me to look back and see that I got everything, but you actually don't need to use parentheses because PEMDAS would take care of the fact that all the multiplication would be done first anyways. So looking at the fact that that 2 is in the thousands place, I would start with 2 times 1,000 to represent the fact that it's in the thousands place. Then we're essentially saying, okay, well then this number is 2,000 plus 500. So because that 5 is in the 100 spot. So 5 times 100. Then we also have that 40 because the 4 is in the 10 spot. So 4 times 10. And lastly, that 3 is in the 1 spot. So it's 3 times 1. And that's it. That's what expansion would mean. So again, you don't need to have the parentheses, but you can kind of see how it looks nicer because then you can really make sure that, okay, I have 4 sets of parentheses because I have 4 numbers, and it's easier to kind of look back at your work. So now let's expand it a little bit. What if we had decimals in addition to this number? So I have pretty much the same number, 2,543, but I also added on 0.12. So let's take a look at what we need with that. Obviously, the first 4 parts of it is exactly the same, so let's copy that down. So all of it's the same because we still had our 2,543, but now we need to add in that 0.12. So what place is that 1 in? That 1 is in the 10ths place. So it's 1 times 0.1 because it's saying that 1 goes as where that 0.1 is. Then secondly, well, where's that second 2 come in, that 0.02? It comes in the hundredths place. So that goes 2 times 0.01. And that's it. So regular expansion is pretty much the same as decimal expansion. It's just you're showing where that decimal place is. So now what if I just had a decimal, 0.273? It's the exact same thing. That 2 is in the 0.1 spot or the 10th spot. That 7 is in the 0.01 spot or the 100th spot. And that 3 is in the 0.001 spot or the thousandth spot. And that's all you need to do. So there's one more underneath this. I want you to try it on your own to make sure you really understand this. If you're having issues with it, ask me during class. And that's it for this lesson.